Content accessible network. Content accessible network. It has basic three operations: insertion, search, deletion, and key value pairs. So the D stands for dimensional logical Cartesian space organized as a D-torus logical topology. Space partition dynamically among nodes, that is, node I has space R of I. For object V, its key R of V is mapped to a point P in the space. Analogously to receive object V, three components of CAN. Setup CAN virtual coordinate space partition among the nodes. Routing in virtual coordinate space to locate the node that is assigned the region corresponding to P. Maintain the CAN in spite of node departure and failures. CAN initialization. Each CAN has a unique DNS name that maps to the IP address of a few bootstrap nodes. So what's bootstrap? Tracks a partial list of nodes that it believes are currently in the CAN. A joiner node queries a bootstrap node via DNS lookup. Bootstrap node replies with the IP address of some randomly chosen nodes that it believes are in CAN. The recipient of the request routes the request to the old owner of the region containing P using CAN routing algorithm. This also helps to methodologically merge region if necessary. The joiner learns the IP address of its neighbors from the old owner. So the new joiner as well as the old joiner inform their neighbors to changes to space allocation. In fact, each node has to send an immediate update to its assigned region, followed by periodic heartbeat refresh messages to its neighbor. CAN routing. Straight line path routing in Euclidean space. Each node's routing table maintains list of neighbor nodes and its IP address. Virtual Euclidean coordinate regions. To locate the value V, its key K of V is mapped at a point P. Knowing the neighbor's region coordinates, each node follows a simple greedy routing by forwarding the messages to the neighbors having coordinates that are closer to the destination. CAN maintenance. So first one is voluntary departure. Hand over region and key value tuples to a neighbor. Neighbor choice. Formation of a convex region after merger of region, otherwise neighbor will smallest volume. However, regions are not merged and neighbors handle both regions until background reassignment protocol is run. Node failure detected when periodic heartbeat message not received by the neighbors. They then run a takeover protocol to decide which neighbor will own dead node region. Despite takeover protocol, the key value tuple remain lost until background region reassignment protocol is run. Background reassignment protocol for one of one load balancing, restore one of one node to region assignment and prevent fragmentation. CAN optimization. Multiple dimensions. As the path of length is O of d n1 by t, increasing the number of dimension decreases the path length and increasing routing fault tolerance at expense of larger state space per node. Furthermore, the multiple copies of each KV tuples offer a choice. Routing fault tolerance also improves. Use delay metric instead of Cartesian metric for routing overloading coordinate region by having multiple nodes assigned to each region. Use multiple hash functions. Equivalent to using multiple realities, topologically sensitive overlay, this can greatly reduce per hop latency. CAN complexity. O of d for a joiner, O of d by 4 log n for routing, node departure O of d2. Thank you.